Hey everybody, so welcome to the Quarter 2 review for Algebra, already in the second 9 weeks of the review. Our first problems that we're going to have up today should be fairly common, similar to us as we look at this. It's wanting us to determine what is the rate of change. Is it constant? Find the rate of change and explain what it represents. So first thing is you have to see, is the rate of change constant? Well, in order to find rate of change, that is slope. Notice in this particular diagram, if this is our table, these are our x's, these are our y's. These are the independent variables, these are the dependent variables. Normally we can look at it and say, hey, so from the change from one to the next, but look at it, it's not going, x isn't changing at a constant rate. You have 0, then it goes up 4, then it's 3, then it's more. So it's not constant. So we can't just simply look at it and say, oh, I can see that every time that these change from here to here, oh, this is a constant change. This is a constant change. This doesn't work for us. What we do have here is we have a bunch of points, a bunch of ordered pairs, a bunch of x's and y's, and we have a formula for slope. We have y2 minus y1 divided by x2 minus x1. This is our slope formula. So if we have a bunch of ordered pairs, it's fairly simple. You can take a look at this and you can do 20,000 minus 17,600 divided by 4. Nope, I just did that wrong. 0 minus 4. So remember, x2, y2, the x here sits underneath its y. So we did these two, subtracting these two. And then all you have to do is plug that into a calculator, do your math. So you have 20,000 minus 17,600 is 2,400. And then you have 0 minus 4, which is a negative 4. Well, clearly this fraction simplifies to negative 600. So take a look at this. These are minutes here. So for each minute that passes, it's going down 600 feet per minute. So we look at it. No, this is not a constant rate of change. It's a positive 300 per minute. It's a negative 300 per minute. It's a negative 600 per minute. There is your response there. A table of values is nothing more than a bunch of individual little points that you can put together. You can stick it into your formula and then be able to simply find your slope. Let's look at the next one. Explain what the rate of change represents. So it says it represents the speed of an airplane. Sorta. It represents the number of feet the airplane will be from the ground after 1 minute. Okay, maybe. It represents the number of feet the airplane descends per minute. So here's the key word here, descend. Descend means to go down. A negative slope, like we just said here, a negative slope is going down. The problem is talking about airplane descent. So it is what? It is the number of feet that the airplane descends per minute, because we ended up calculating this as a per minute thing. Time is in minutes, and the y-coordinate represents feet. Descent per foot per minute. Next one, find the slope of a line shown on the graph. Okay, there's two ways we can do this. If you're given a graph that has, as this one is, the margin is clearly identified. 1, 2, 3, 4, 5, 6. The y's. 1, 2, 3, 4, 5, 6. Very easy to see. They don't give us the points. We can find this point. If we wanted to use our formula that we just had above, y2 minus y1 divided by x2 minus x1, you can find the points, ordered pairs. So it goes to the left, 1, 2, 3, and down 1. So -3, comma, -1. And this one would be 4, 2. There's your points. You could apply the slope formula. Here's an easier way to do it, guys. Why do you want to make more work? We can just easily do this. So even if we didn't have this, we were feeling maybe a little lazy, didn't want to do it. Great. Watch. You can use rise over run to find your slope. So rise over run means they gave us two identified points. There's a point there. There's definitely a point there. We rise, we're making a 90-degree angle. So we have to go from this point to this point via a 90-degree angle. Are we going up or down? If you go up, it's a positive number. If you go down, it's a negative number. So we're going to go up. 1, 2, 3. 3 points up. And then you're going 1, 2, 3, 4, 5, 6, 7. So we went up 3. The rise was 3, and the run, so the rise was 3, and the run was 7. Does 3 over 7 reduce? No, it can't. 3 and 7 are prime numbers. There is your slope. The slope is 3 over 7. Notice, same thing for the next problem. They want you to do the same thing. Again, I don't care how you figure it out, whether you find the points and you use the formula, or you do rise over run. And the run. 1, 2, 3, 4. And you represent it as a fraction. Okay? Here we go. Use the slope formula to find the slope of the line that goes through a given point. All right, so you have 1 point here, 1 point here. You're going to use your formula again. y2 minus y1 over x2 minus x1. Be very careful when you plug your numbers in. Notice we have these different things. So you go to plug them in. All right, doesn't matter which point, put the y over the x. 0 over the 6 minus -6 over the 2. Keep, change, change, keep, change, change. And then you do your math. 0 plus 6 is 6. And you have over here 6 plus a -2 is a 4. So -6 oh no, I'm sorry, +6. No, -6. -6 over 4 becomes what? We have to reduce. How many times does 2 go in a 4? 2. 2 goes into -6. 3 times. There you go. -3 over 2. You have reduced the fraction. If you put your answer in like this, it will say it's wrong because you did not reduce your fraction. Please, please, please be careful and make sure you fully reduce your fractions. Now, here we go. Another one. What's the slope of the line? 2 ways again, 3 ways again to figure this one out if you really want to do it. You can do rise over run. Okay, does the graph go up? Does it rise at all? No, so it's 0. How many over does it go? 1, 2, 3, 4, 5, 6. 0 divided by 6 equals 0. There's your slope. You could take it and put it in the slope formula. -5 minus -5 divided by -3 minus 3. Okay, you do that and you'll find out. You get a slope of 0. Or you can remember our little friend, Mr. Slope. Notice that his nose and his mouth always dictated certain things. This is what a positive slope looks like. That's what a negative slope looks like. A vertical line is undefined, and his mouth, which is a horizontal line, is 0. That's why there's zeros on the end. So you can use Mr. Slope to find slopes. 6. Here we go again with this is word problems. Without graphing, tell whether the slope of the line that models the linear relationship is positive, negative, 0, or undefined. Then find the slope. So a babysitter earns $9 for 1 hour and $45 for 5. Guys, this is two separate pieces. Here's one, and here's the other. We have to put these into ordered pairs. It's two ordered pairs, but we have to think logically. What is our x value? What is the independent variable? What does the price depend upon? Well, you can't set a price without knowing what? How much are you going to make? Depends on how many hours you work. Okay, so that means our independent variable is going to be the hours, 1. Well, if you work 1 hour, then you make $9. If you work 5 hours, then you make $45. And then what do? You use our slope formula. Y2 minus Y1 divided by X2 minus X1. Keep, change, change, keep, change, change. Do the math and reduce. And you'll figure out whether it's, you don't even have to really do all the math. You're just trying to figure out, is it undefined? Is it positive? Is it 0? Is it negative? Remember, an undefined slope is when your denominator ends up being a 0. So be careful, okay? Only if your denominator is a 0 is it undefined. It's the only time it'll be undefined. And of course, once you figure that out, they actually want to know, well, what is the slope? So calculate it all the way out. 7, again, use the slope formula. So you're going to have to do the same thing again. Y2 minus Y1 divided by X2 minus X1. Keep, change, change. Keep, change, change. Reduce and figure it out. Here we go. This is exactly what we did on quarter 1. It comes back again. Can we graph an equation in the form y equals mx plus b? Remember, b is your y-intercept, m is your slope. So the first thing we do is plot your 5 on your y-axis, and then you apply the slope. Even though it may not look like a fraction, this is technically a fraction, 4 over 1. The rise is 4, so from 5, you would go up 4, and you go to the right 1. Okay, 5. You go up 4, 1, 2, 3, 4, and over 1. And it draws your line for you. Be careful, guys. That's it for the first day of our quarter 2 review. If you are actually watching these videos, you'll realize the review is pretty easy if you're watching the videos. So I need you to get out there now, open up your Math Excel, and start your quarter 2 review. Have a good one.